Have you ever pondered the possibility of traveling through time? A question that has undoubtedly crossed your mind at some point, either out of sheer curiosity or perhaps a longing to alter the past or glimpse into the future. Time travel, a concept that has intrigued humankind for centuries, is more than just a recurring theme in science fiction novels and blockbuster movies. It's a concept that has tickled our imaginations, stirred our deepest desires, and spurred countless debates. From H.G. Wells's The Time Machine to the Back to the Future trilogy, our fascination with time travel is clearly evident in our literature, our films, and our daydreams. But what exactly is time travel? At its core, it's the idea of moving between different points in time, much like we move in space. It's about hopping from one era to another, witnessing history unfold or the future take shape right before our eyes. Yet, as exciting as it may sound, time travel isn't just a simple leap forward or backward. It's a complex theoretical concept that delves deep into the realms of physics and philosophy. It challenges our understanding of the universe and our place in it. It prompts us to question the nature of time itself. Is it linear or non-linear? Can it bend and twist? Can it be manipulated? The scientific community, while intrigued by the notion, remains largely skeptical. Theoretical physicists have proposed various models of how time travel could work, from wormholes to cosmic strings. However, these theories remain unproven, and the practicality of time travel is still widely debated. It's a subject that divides opinion, with some scientists arguing that it's theoretically possible, while others dismiss it as pure fantasy. So is time travel merely a figment of our imagination, or could it actually be within the realms of reality? As we delve deeper into this enigma, you might find that the answer is not as clear-cut as it may seem. The question of time travel, it seems, is as elusive as time itself. Albert Einstein once said, "The distinction between the past, present and future is only a stubbornly persistent illusion." This illustrious physicist opened up a whole new world of possibilities with his groundbreaking theories, including the tantalizing prospect of time travel. Einstein's theory of relativity, a cornerstone of modern physics, fundamentally changed our understanding of space and time. It told us that these two concepts are not separate entities, but interwoven into a single continuum, space-time. In this four-dimensional fabric, massive objects cause it to curve, creating what we perceive as gravity. Now, here's the kicker. If space and time are interconnected, then bending space should also bend time. This idea, as radical as it may sound, is what gives rise to the possibility of time travel. According to Einstein's theories, under specific conditions, it might be feasible to curve space-time so drastically that it loops back on itself. This forms what we call a wormhole, a sort of shortcut through space-time. Imagine you're trying to reach the edge of a piece of paper by traversing its surface. It's a long journey, right? But what if we could fold the paper so that the edges meet? The distance between the 2 points suddenly becomes negligible. That's what a wormhole essentially does. It connects two distant points in space-time, potentially allowing us to travel vast distances in a flash, or even journey into the past or future. Now, it's crucial to note that while the mathematics of relativity allows for the existence of these wormholes, we've yet to observe one directly. Moreover, even if they do exist, a whole host of other issues, such as stability and survivability, come into play. But isn't it fascinating, the thought that one day we might step through a portal and emerge in a different time? Einstein certainly thought so, and his theories, as we've seen, provide a scientific basis for such a possibility. So, if Einstein's theories hold, we might be closer to time travel than we think. But here's a twist. What about the paradoxes associated with time travel? Now, we've all been there. Sitting in a comfy chair, getting lost in thought, and suddenly we're pondering about time travel and the many paradoxes that come along with it. It's a mental rabbit hole that's as fascinating as it is perplexing. Let's start with a classic, the grandfather paradox. This theoretical situation asks a tantalizing question. What would happen if you traveled back in time and accidentally prevented your grandparents from meeting? If they never met, your parents would never have been born, and consequently, neither would you. But if you were never born, how could you have travelled back in time to prevent your grandparents from meeting in the first place? It's a mind-bending loop that defies logic, and yet it's a question that's essential to our understanding of time travel. Another paradox that's sure to pique your interest is the bootstrap paradox, named after the phrase, pulling oneself up by one's bootstraps. This paradox deals with objects or information that exist without any discernible point of creation. Imagine this. You're a time traveler who loves Beethoven's music. You decide to go back in time to meet the maestro himself, only to discover that Beethoven never existed, but you have all his music sheets with you, so you publish them under his name. Fast forward to your original time, and Beethoven's music exists because of you. But where did the music originally come from? It's a paradox that leaves us scratching our heads and wondering about the intricacies of time travel. These paradoxes, as mind-boggling as they are, serve a crucial purpose. They push the boundaries of our understanding and force us to question our assumptions. They highlight the potential problems and inconsistencies that could arise if time travel were possible. They make us think, question, and ponder. And that's the beauty of it. These paradoxes certainly add a layer of complexity to our understanding of time travel. After all, what's a discussion about time travel without a good paradox to keep things interesting? Despite the paradoxes, some scientists believe time travel might still be feasible. One of these scientists is physicist Kip Thorne, renowned for his groundbreaking work in the field of astrophysics. Thorne has proposed that time travel might be possible through the use of wormholes. Wormholes are theoretical passages through space-time that could create shortcuts for long journeys across the universe. These tunnels through space-time are predicated on Einstein's theory of general relativity, which describes gravity as the warping of space-time by energy and matter. So in theory, if matter and energy could warp space-time strongly enough, they could form a tunnel connecting two distant points, a wormhole. Thorne suggests that by stabilizing a wormhole with a form of exotic matter, which theoretically might have negative energy density, we could keep this space-time tunnel open. And voila, a pathway through time and space. However, it's essential to remember that these concepts are deeply rooted in theoretical physics. The existence of wormholes and exotic matter is still yet to be proven. Then there's the concept of quantum entanglement. This is a strange phenomenon where two particles become linked, and whatever happens to one particle will instantaneously affect the other, no matter how far apart they are. Some quantum physicists propose that this connection could be a form of wormhole or quantum tunnel, and might be utilized for time travel on a quantum level. However, these theories are not without caveats. The very idea of time travel and its potential implications still pose many questions and paradoxes that science is yet to unravel. And while the current understanding of physics might allow for the possibility of time travel, the practical implementation is a whole different ballgame. While these theories are still largely speculative, they keep the door open to the possibility of time travel. As we continue to explore and understand the universe, who knows what fascinating discoveries lie ahead? Perhaps one day we might just find ourselves stepping through a wormhole to another time. So, what does the future hold for time travel? A question that has piqued the curiosity of many, from seasoned scientists to sci-fi enthusiasts. The future of time travel is as exciting as it is uncertain. A significant part of this future lies in the hands of quantum physics, a field that continues to redefine our understanding of the universe. Quantum physics, with its dizzying array of particles and probabilities, might just hold the key to unraveling the enigma of time travel. Quantum entanglement, a phenomenon where two particles become inexplicably linked, has been suggested as a potential vehicle for time travel. Though still in its infancy, this research could radically change our perception of time and space. The quest for understanding time travel isn't just about building a time machine or unraveling the secrets of the universe. It's also about nurturing our scientific curiosity and the relentless pursuit of knowledge. It's about asking the big questions and not being afraid to venture into the unknown. Scientists and researchers across the globe are dedicating their lives to unlocking the secrets of time travel. They are pushing the boundaries of what we know and understand, driven by a desire to explore the uncharted territories of our universe. Each new discovery, each breakthrough, brings us a step closer to understanding the true nature of time. But as we peer into the future of time travel, it's essential to remember that the journey is just as important as the destination. The pursuit of knowledge, the thrill of discovery, and the joy of understanding are what truly drive scientific exploration. While we may not be packing our bags for a trip through time just yet, the journey to unravel the mysteries of the universe continues. The future of time travel may be uncertain, but one thing's for sure. Our quest for understanding, our thirst for knowledge, and our passion for discovery will always keep us on the path to the future.